All right. Let's do it. Okay, let me bring it up. What have we got here for, let's see, Ricky Henderson? I don't recall this guy. Compiling C to safe Rust formalized. Okay, good. Looks like a winner to me. Do I understand any of it? Probably not. Okay, let's go to... Oh, I'm gonna change my desk a little bit. Okay. Let's go to the exorcism. Okay, so how are we doing here? So here's the challenge. So it looks like so far we have completed how many? I have completed 129. Right, so there are 15 left. Okay, so let's jump right over to this one, Minesweeper. Okay. So we're going to paste that and jump right in there. Faro small talk. That's what we want. Okay, so Minesweeper. Okay. So I'm going to first look at the help to try and remind myself of how we use this Faro small talk. I remember it being a little bit hard or intimidating to get started in the first place. I think it shouldn't be bad this time. We'll see how it goes. Okay, so tests can be run directly from the Faro IDE. So they strongly encouraged you to use this. Does it say how to open it? So if we just go Faro, is it just far? Wait, what is it? Okay, what's far? No command given. PHP archive, so that's not it. What's the one I actually want? It might not be added to my path. Let's see. What files have we got in here? And let's view the README as well. Okay, so this is just about what we're doing. It's a very simple, we're just given a board and we're supposed to put numbers in it, right? So easy peasy. I don't recall how to get started with Faro. Okay, so let's take a look. It was a while ago. It took me forever to do the hello world. And then we did the Roman numerals, and now we're on the Minesweeper. So, let's see. You can unlock mentoring slots by grinding reputation. What the? You can donate to unlock all? Alright. Crazy. Look at this guy. Glenn Jackman. 46K. 46K reputation. That's madness. Currently a mentor in JQ, Awk, Bash, Lua, Teakle, and Faro Smalltalk. Wow. Alright, so that guy is a stud. Let's go to this one, and this one, and this one, and this one. Okay, so let's see. Installing. Let's see. So there's supposed to be a Faro UI. Oh, yes. Okay. So I have a Faro UI up up in there. All right, so when we grab that Faro UI, we use this load script. Okay. I mean, yeah, that's what I think that's what I did before. Oh, shoot. I think that's what I did before. I don't think I have to do anything with an iceberg or whatever. Okay. So I'm gonna, yeah, so I'm gonna leave that text in there, I guess. Faro image eval. I'm just gonna make this ... Faro UI, faro.image eval, and then all of that. And then I think it opens up the application thingy. No. Error opening. Oh, okay. So I guess I probably have to go here and do it. Does that make more sense? Okay, so it opened something up on the other monitor. I don't know why I said it like that. Monitor. Okay. So, yes. So we're loading some kind of baseline of exorcism, it says. Going by this bar graphic, it looks like it might be stuck, but we'll see, we'll see. Okay, so hello world. Oh wait, something's happening. Instance of array. Question. Okay, you are about to load new versions. So I'm gonna say load. And then anything else? This is a very interesting application. I don't like the aesthetic of it very much, but it has a lot of functionality. Yeah, I don't know. Okay, so let's see. Windows. Collapse all. What does that do for us? Okay, so these are all different windows down here. Oh, that's craziness. Okay, let's look at them one by one. All right, so this is the hello world. All right, so we don't need to worry about the hello world. So do we want to close that one? Let's see. So let's close the hello world. All right, this is test failure. Okay, so we can close that. This is another hello world. This is from Roman numerals, so that was the previous. Uh-oh. Okay. This is instance of Roman numeral. Okay, so these are bugs. All right, so I don't need to look at any bugs right now, I don't think. I don't need to look at any hello world right now, I don't think. I don't think I need to look at any Roman numerals. Is it okay to discard changes? Yes, yes. Okay, so then what are these? These are all an alpha image morph. Oh, this one's a system progress? Wait, where did it go? Oh. Huh. Okay. Alright, so I guess the windows are all closed, except what is this? What is showing here? Okay. So, uh-oh, I'm gonna be in trouble. So let's go to fetch new exercise, and we're gonna put in Minesweeper, and say okay. And then what does that do for us? Okay, so here's Minesweeper. So now, if we go here, let's see. So Minesweeper test is open. So this is exercise at Minesweeper. And this one is Minesweeper test. So do we now... Oh, okay, hold on. Okay, so there's a comment here. Oh my goodness, interesting. Hash Minesweeper is missing and does not understand new. Okay. So the first thing we need to do, let's see. Okay, so we're going to try to create a class, I believe. I spent quite a bit of time on this the last time, and man, I find this setup really confusing. I spent quite a bit of time with it. I think I was sort of starting to get it in a way, but man. Okay, so I was distracted momentarily by something. Here, let me text my AI helper friend. AI, what is the capital of Faro Smalltalk? Will it respond? Let's see. What is this? Minesweeper test case. No country called Faro. Smalltalk likely refers to a dialect or programming language. Alright, let's see. Is it a new package? I don't think so. Yeah, you know, I think it would be very interesting to get into this with like a tutorial, something to like tell me how to get started. Last time, I didn't really look at a tutorial for Faro Smalltalk. I just tried getting started. Oh wait, actually, yes, I did. I looked at something that eventually helped. Okay, let's look in the history. Faro. Was it this? October 21st? Faro, the immersive programming experience. Okay. Access the Faro MOOC. Okay. Some introductory casts. All the syntax and model explained on 2 pages. For Ruby people. Okay, I think I did look at this. Now, is there something here to help me? Packages, okay. Classes. Okay, wait a minute. New class. Minesweeper. Save. Uh-oh. I don't think it went where I wanted it to. Oh, that's right. Okay, so this was something that threw me off a lot when I tried this before. So if you click here and it's opened already, and if you click again, it closes it. And I didn't understand that. Okay, so we're gonna go new class, Minesweeper, save. Yeah, I think this is what I really want to do. Ah, okay, good. Okay, so object subclass Minesweeper. Okay, so now if I come back into the test and try this, did not understand annotate minefield. Okay, so we're going to find this class, and we are going to add an instance side method, and it's going to have a name called Annotate minefield. Okay, I think I'm getting it. Oh, wait. Declare new temporary variable. Okay. Okay, so methods. Annotate minefield. Save. Okay, saved. So now we go back to here, and what's it say? Did not understand annotate minefield. Okay, so I tried adding an annotate minefield here, but apparently it still didn't understand it. So what does that mean? Minesweeper calculator, annotate minefield. Ready? Is it going to be the same thing? Okay, so did not understand hash annotate minefield. I want to say annotate minefield is probably the method, right? And so if we go into Minesweeper, instance side, something is as yet unclassified. Okay, so annotate minefield is here. Okay, what does this say? Semantic warning uninitialized. Is that any better? Save. Okay. So when we have a method, as I recall, there was a pretty detailed explanation. I don't think it was in a wiki. There was something pretty detailed. It was like a book, like a PDF, I think. And it, what did it do? It basically walked me through creating a method and stuff like that. Was it this, maybe? No. What would it have been? Oh. Faro cheat sheet PDF. Okay, what about this part? Ah, yes, this was it. Okay, so we have the Faro launcher opened. Create a package and a class. Okay, yeah, if we go through this walkthrough, I think I'll be able to get something to happen. All right. So I think we have the package already, I believe. So I'm gonna skip ahead a little bit. Let's see, write some failing tests. Okay. Exorcism did provide us with some failing tests. So I'm gonna skip ahead a little bit. Okay. Okay, now add methods to make tests green. Init. So when I tried the test, it didn't seem to be saying that we needed an init. I think, or I was thinking the init might be good. What does this say here? There's some kind of red, oh, it says there is no comment. I'm actually pretty tired today. Um, okay, so annotate minefield is supposed, wait a minute, what's this? Unclassified methods? Oh man. Um, oh no. Oh man. Um, I don't know what to think when it comes to Faro small talk. It's a trip, man. Things beginners must learn. I don't think I looked at this before. I am losing it. Okay, so example, my method. Hmm. Yeah, if I'm being very honest, I don't think I like Faro small talk. I think it would take a while for me to become initiated into it and learn to like it. Hmm. Must know for beginners. Hmm. Um, Let's see. What am I wanting to say about this? I feel like laying down and closing my eyes. But let's, yeah, so I mean, like last time, what the thing that I want to do is pretty simple. Do I have code here still from something from before? Oh yeah, this looks okay. Roman number, an integer, sets Hey, look at this. How did I figure all this out? I do remember it took me forever, and this code style is absolutely horrendous. Absolutely horrendous. Um, so I got through it. Okay, so I want to keep this open. Actually, okay, let me just copy all of this. Okay, so now come back to Minesweeper into annotate minefield. I'm gonna paste. Oh no, what in the world? Okay. Alright, so it looks like it should give back something, probably. Okay, so if we look at the test, hash, okay, yeah, yeah. I will say the syntax of Faro Smalltalk, I think it has a nice aesthetic. Like once you actually get in here, like this is a horrible, horrible style that's like all if false like crazy. But even so, like I think there's something appealing to me about kind of the way the syntax is. Maybe. Adds numbers to Minesweeper mine. Alright, so my arrow keys not wanna help me. So was an integer passed in here? Oh, yeah, okay. Why do my arrow keys not work the way I want them to? Oh gosh. Oh gosh. Okay, so... Oh, man. Um... So now we are going to do some kind of a loop. So let's look at where do we have like looping. So I guess the cheat sheet probably has most of it, right? Okay. Um, oh man. Common constructs. Okay, so we're gonna go for string row minefield. Where's the dot go? Hmm. And then is any of this going to help me? There's a if true, while true, there's a if false. Okay, so I'm going to go ahead and drop that from here for now. It says 4 is not a known variable. Oh, that's the comparison to Java. Okay, whoops. Okay. Minefield do each Now what does the test say? Does it now say that it's a thing? It still says did not understand hash annotate minefield. Ah, okay. Got a minesweeper instead of nothing. Okay, so now if we do this, where is it? Here. Okay. Got a minesweeper instead of... Okay. Did I save what I had done? No, I didn't. Okay, so that turned green. Okay. So now there should be something in there, right? So we are gonna go... So, man, it opens up a lot of things, it seems like. Close. 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 Where? What is this? Implementers? I don't know. Okay. Close, 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 close. Uh-oh. Uh-oh. Is it locked up? It looks like it. Oh man, I don't like that. Seems bad to me. Okay, so if it's locked up, I'm just gonna have to close and start it again. Alright. Mm-mm-mm. Close this and this. Okay, let's do it again. Opened up over there again. Oops. Okay. So something is trying to happen, I guess. There was something about, oh, a question. Let's load. Huh. So it looks to me like because it locked up and I had to close it like not the proper way, it looks like whatever I had done was like not saved. That's rather sad. All right, let's try to get this to turn green again. Okay, exercise Minesweeper. Where's new class? Where's new class? Shoot. Where Wasn't new class here? Okay, so exercise, Minesweeper. Shoot. I just want to get past this one, man. Wow. Okay, so if I try to do this, Minesweeper is missing and does not understand new. Where's new class? Ooh. Oh, is it class side? Oh, man. I'm a little disappointed. So, I just did all that. It locked up. I lost all progress. Sure, fair enough. It happens. But now I can't even figure out to get back to where I did the very first step. Before, there was a tab here somewhere. No, wait. There was a tab here somewhere that said new class, and then I just put the new class in there. So where is it now? I mean, yeah, I guess. Okay, so we're going to... Is it system browser? Yeah, maybe. So we're going to find exorcism, Minesweeper, new class. Here we go. Great. So the class is going to be called Minesweeper. Save. Okay, now this is going to have an instance side method, which is called annotate minefield, and a minefield gets passed in. Okay, so then we just return the minefield that we got, save that. Now we go over to the test, and that one turned green, and that one turned green, and that one turned green, and that one turned green. Okay, so 4 of them turned green. So now what I want to do is I want to save and quit. Okay, so hopefully now I won't lose progress again. So let's open it again. Opened on my other monitor again, that's fine. Okay, so great. So now we actually have to put some numbers in, right? Wow. Yeah, I mean, I don't know. It seems like kind of an ambitious project that they've done here. I don't know what I mean by that. It seems like it might be kind of overly ambitious, right? Like this doesn't look good, obviously. I don't know. Question? You're about to load new versions of the following packages that have unsaved changes. Okay, I'm gonna try load, but then let's see where we're actually at. So test. Okay, so if I hit this again, is it still green? Okay, so now what? What just happened? What? I've got somebody's implementation here. How did this happen? Where did that come from? What the what the heck? It's a very nice implementation too, I think. Hold on. What's 8 neighbors here? Where's 8 neighbors come from? Why do I have an implementation of it, though? Like, where... What the heck, actually? Faro, small talk, 8 neighbors. Where's 8 neighbors come from? Where's this defined? Oh. Oh, these are extension methods or something. Wait, I'm not sure. Neighbor value in at mine at mine at I'm interested in this because this right here is actually doing most of the work, I think. Right? So where is that implemented? This 8 neighbors is most of the work. Huh. So a lot has happened here that has confused me a lot. I for the life of me, I can't imagine why it loaded an implementation. Um, that's crazy to me. I'm very curious about this 8 neighbors, because I think that's doing most of the work, basically. Um, it should be on array, but I don't see it. Oh, what did I just do? Collapsed or something? Okay, browse. Spotter. 8 neighbors. Okay, so here it is. Um, right? So check that out. That in my opinion is most of the work of this problem, right? So where does this one come from? Is this actually something that's sort of a default part of the standard library of the kernel? Kernel basic objects point. Let's look. Faro small talk kernel basic objects point. Um, online info. Hold on. Okay, so wiki. General language. Okay, so how about search wiki? So by the look of this, so this is in kernel. Um, These comments are about the point. Okay. So yeah, it looks like this is part of the standard stuff, and that 8 neighbors, that seems nice, right? Seems real nice. So that was basic objects, point, 8 neighbors. Okay. So, yeah, this is a trip. So I did not see or understand why it loaded the solution, and I don't know what to do about it. So I'm going to skip ahead and I guess come back to Faro Smalltalk at some later date. Because I don't know. I mean, it looked like a very nice solution, clever, made use of the standard library. That one annoyed me in a way that none of these others have annoyed me. Because none of these other problems ever, like, popped up a solution like that. That's crazy. That's crazy. Okay, let's try D&D character. So I had some trouble with D&D character in Unison. I am going to try it in Elm and see if I have better luck. Okay, I'm going to close this, or I'm going to, I guess, save and quit. I am baffled. I do not understand what it was doing. Okay, so we're going to go to Elm, D&D character. Let's give it a shot. Okay, so I've got a D&D character Elm file. So let's go ahead and open that up. Oh, okay, cool. Look, this is nice. All right, so yeah, this doesn't seem bad at all. Okay, so let's see if I remember this part. So this part is the simplest, right? So we have a modifier. We have to, I think, subtract 10 and then divide by something. Was it by 2? I think so. So we're going to go score, subtract 10, divide 2. It was something like that. Floating point. Do we have an integer? Okay, so now let's see what the test says. So I got -3. It was supposed to be -4. Okay, so I'm just gonna look at the README. It tells me what's wanted. So for the score, subtract 10, divide by 2, and round down. Okay, I guess we kind of rounded up there. And so in Elm, int functions, basics, okay, so I used integer division, but that truncates. We need to round down. Floor. So is it number floor? I think so. So we're gonna get rid of that. I'm gonna say this, and we are gonna say int floor. So we think it's number floor? No. Could it just be floor by itself? Okay, and then this would be to float score test. Okay, so that ran. All right, let me check my sound. Okay. So now let's unskip some other tests. Passed one, or okay, so two passed. Next. Three passed, okay. Surely it won't. Four passed, oh my gosh. Is it just a lot of tests? I think it's just a lot of tests. That's cool, though. Well, no, it's fine. There's nothing wrong with a lot of tests, but these tests are clearly redundant, so well, I don't know if cool is quite the word, but sure, having a lot of tests is fine. Man, so many. I'm looking for the first one to fail. Yeah, somebody added a lot of tests here. Okay, here we go. So now we are going to generate an ability. So this is something that we do using like dice rolls or something like that. So I see that it says random.lazy, and then something happens, and we're like debug to do, and we're like, please implement ability. All right. Okay, so oh, you know, it's asking to install Elm language server, but I've already been super happy with the hints that I get in the editor, so I'm not going to do that. Okay, so here's Elm. So let's look for random. Well, it's not here. Where would it be? Platform? Okay, let's look. Elm programming language, random lazy. So random lazy is what it said. Okay, so we're in Elm packages. Now we're in random. So this is where I was before. How come when I put in random, I didn't get anything? What's the difference? So this one... So this is in core. So to find random, I guess I have to go out of core. So core, Elm. Ah, okay. Random. Elm random. Okay, cool. So it'll be import random. Do we have that already? We do. So we have import random exposing generator. So that sounds fine. So then we have our function. Okay, so here it's marked generator. Let's take a look. So what is the nature of generator? Mindset shift. Yeah, this seems fine. Okay, so package random 1.0.0. Okay. A generator is a recipe. Elm recipe. Okay, so I don't think recipe is hold on. So I don't think recipe is like a, what do you call it? Like a term, a vocabulary term. I think they're just saying it's a recipe. Why and how we retired elm. Okay, so they're just saying, well, it's bolded, so I was thinking, oh, it must be a special term, but I don't know. A generator is a recipe for generating random values. Okay, so I guess this is fine. So I'm just gonna try to create a list and like sort it. What's the lazy though? Random lazy. Check out the docs for lazy to learn why that is needed to define a recursive generator like this one. Okay, so I'm gonna say elm list. So we want a list of 4 random ints, right? So I'm not sure we want any of this. I think we want to do a list of random int, right? So lazy map data structure int. Okay, random int, and it's going to be in the given range. Inclusive? I'm not totally sure, but basically it's 1 through 6. Right? Okay, so then once we have the randoms, then I think we sort. So sort list sort those, and then we're gonna add together the first 3. So I guess take, yeah, so we'll take 3. List take 3. And then we'll sum those. So let's see if sum is here. Oh, it looks like it. Yeah. So that should be easy. We'll see. List sum. All right, so now something is off with the body of... Okay, so only int and float values work as numbers. Okay, so let me clear and look at this. Something is off. The body is number, but the type annotation on ability says it should be generator int. Okay. So now I think we want that lazy. Helper for defining self-recursive generators. This argument is a list of type list generator int. Sort needs the first argument to be list comparable. I do not know how to compare generator values. I can only compare ints, floats, char strings, lists of comparable values, and tuples of comparable values. Check out whatever for ideas on how to proceed. Okay, so interesting. So I think the stub had that lazy in it. I think that was a hint. I think that lazy was a hint that what we're going to do is use recursion probably, so we're probably not going to use a list at all. Okay, so roll is going to be int generator int, I think. Roll n. So that's the number of rolls, basically, I guess. So if n equals 0, then 0, else random int 1 through 6 plus roll n minus 1. Okay, so now for generator, constant. Addition does not work with this value. Okay, understandable, understandable. I guess. Add. Yeah, honestly, I think that this does make it trickier. The fact that we can't just sort of, like, say, give me a random int, right? It does make it a bit trickier. So there's a learning curve, I guess. Okay, so we can't do addition with a generator int. What do we need to combine generators for? So they chose random map. Oh. I am not too sure. Okay. combine two generators. Huh, interesting. So technically, I guess we could try using map 4 to combine 4 generators, maybe? Like, what is that gonna do? So they did random map 4. And then what was node here? Okay, okay, fair enough. And then, okay, so what is fancy about this? Okay. Really interesting. So let's try, let's try not doing this. Whoops. So instead of doing this, it's going to be random list, and we're going to put in random int 16. Okay, now what's that say? Okay, so now we're going to list 4 of them. Okay, cannot send this through the pipe because, what does it say? Okay, so it's a generator list int, but piping it to a function that expects list comparable. Okay, but we can try and then. Okay, so let's take a look again. All right, so we'll do, so I guess we're not gonna do these. So and then is supposed to take a function of A to generator B. Okay, so let's say we have roles, which gives which is a generator of a list int, sure, and then, oh, but let's say it takes an int to say how many, and then n equals random list n int 1 through 6. To actually get random values, you create a command. Oh. Commands are one of the core concepts in Elm. Okay. Okay. Um, cheap viewers on streamboo.com. All right, I'll try to concentrate and we'll figure it out. So we're gonna go roles for random and then roles list Okay, so that can be used as a number now. Okay, great. So then we're going to go list sort roles list list take three list sum Okay, so what's that say? So I've got a list of number to number. Needs the first argument to be list of number to generator B. Okay, okay. So generator is all over the place, right? I think it worked. Oh my gosh. Okay, so that's not so bad. That's not so bad. I had no idea what was going on. But that is perhaps not so bad. Okay. 13 has an approximate 13% chance of being picked. So distribution expected around 10%, got 4.56%. Okay. So we did not get it right. Oh, I think I have to reverse. Okay, let me go ahead and change, or you know what, let's just do like that. Okay, so that's better. Okay, next. Okay, so this one we haven't done yet, right? Okay, so for this one, generated character strength should be within range. Okay, almost there. So the generator works. That was the part that was the biggest learning curve for me, I think. So now we are gonna go... We're gonna do what? Let's see. So... So the type alias character, that's a record, right? So I need to review Elm record type, I believe, right? Or perhaps not. Okay, so Bill, okay. Character attributes, generator character, strength, Okay, so type alias. We said hypotenuse point to float. Record type aliases are extremely common in Elm code. So yeah, I've been messing with Elm code a bit, but yeah, not enough yet to really know all that. So I think here we can probably just go ability. There's no way. Is that possible? Okay, so then here, we don't want to do that. We want to do character attributes. Okay, so type mismatch. Something is off. Says it should be a generator character. Okay, so record of type generator int number, generator int. But it's supposed to be generator character. So we want to go So I want to say we could go random list and do like 6. Okay, so I don't think this is necessary. So I want to say we're going to go random list, and it's going to be a list of 6 abilities. And then abilities list. And then we're going to take something off the list for each ability, right? Okay, so we want to use a case. Let's look at a case. Okay, yeah. So then we can go case. Elm case deconstruct list. Uh-oh. Why did it open over there? Okay. So we're gonna go case abilities list of SDCIWCH, right? Strength equals S. Dexterity equals D. And I believe we put commas at the end here. And then intelligence equals I. Wisdom equals W. Charisma equals CH. Hit points equals, and then that's where there's a formula, which let's review it one more time. 10 plus Constitution modifier. Okay, so then this is going to be 10 plus modifier C. Okay. So now, and then is not what I expect. So we have an anonymous function of type list int. Okay, so then should we say for this we want random constant? Seems weird that we would use it that way. And then in the case, I think, is this as it should be? Elma doesn't allow more than 3 elements in a tuple. Hmm. So let's see. So this probably shouldn't be a random list at all, should it? I guess it kind of has to be. Can't we do like true or something like that? What did I mess up? Oh no! Oh no, does the indentation matter? Oh, it does. Oh no. Okay. Some of this is so weird. Okay, let's do all the rest of them. Okay, now I'm gonna try submitting, but then this is gonna need some refactoring, I think. D&D character Elm. Okay, let's close some of these down. We'll see what happens next here. Okay, so did we process? Have we processed? Okay, so there's a robo hint. Good. A way to simplify. You can replace this call by random map. Okay, so let's do that for sure. So we used, in roles, we used random and then. Random and then with a function that always returns a constant generator is the same as random map with... Okay, let's do it. That sounds great. Okay, so this should be map, and then this shouldn't be... Amazing. Let's submit again. Okay, so it says passed. No robo hints this time. Okay, now let's look for ways to possibly refactor here. Okay, so type alias, good. I think this is fine. Seems like a lot of parentheses in this one. I think it's fine. Sure. All right. Is that any better? I would say so. And then do we have Elm? Yeah, let's Elm format. Yes. And test. Okay. All right, so now let's look again. Okay, so we Elm formatted. And okay, yes, nice. Oh, they put the commas at the start. That's fine. Interesting, interesting. Can we do that? Okay, let's Elm format again. Yep. No, let's test again. Okay, let's look one more time. Yeah, cool. Okay, let's submit. All right, so certainly a lot better than that Faro Smalltalk. Something about that Faro Smalltalk still rubs me the wrong way. And I mean, it was already rubbing me the wrong way, but then when it actually like loaded the solution, I I wasn't clear on why. I think it told me something about why and I just didn't understand it. But regardless, like where are you even loading the solution from? It's crazy. Very confusing. So my experience with Faro Smalltalk has not been the greatest. This Elm actually, Elm has really won me over during this 48 and 24. Elm seems so great. Elm has won me over more than any other programming language. Obviously, I still have a lot of skill issues with Elm. There's a lot that I don't know, but it has really won me over. Look at this. A delightful language for reliable web apps. I would like to try creating a reliable web app using Elm because, man, this language has really won me over with these little puzzles, which obviously these little puzzles are nothing like an actual reliable web app. But, man, I'm having such a good time with Elm. Elm has been the #1 out of all the languages I've tried in 48 and 24. Elm has been the #1 that has really won me over. Now, let's go to Unison. And we're going to try this D&D character again in Unison. So now let's look at the Elm D&D character. Okay, so let's just cat that. All right, so we've got that, so we can kind of review that. All right, now let's look at our Unison file. D&D character U. So Unison, generally speaking, I think is somewhat similar-ish to Elm, right? So yeah, if you look, if we cat this D&D character U file, so look at this. This is actually somewhat similar, right? So we have an interface defined for this function. So here we said generator int, and here we said apostrophe squiggle random squiggle nat, right? So it is different, but I think what's similar, so nat is like int basically, but well, a nat is an unsigned int. But this, I think, is another way of saying something similar to this, right? So I think what I want to do is basically try the same approach that I used in Elm in Unison, because I think that's going to make it easier for me. So I am going to cat this into my Unison file. So, okay, so that's copied in there. All right, so now let's open the Unison file. All right. So here, everything from here down is comment. So Unison comment. So we can do a dash dash. Oh, we can just put a fold? Okay, cool. Great, love it. Okay. So I don't need this. I don't need this. I don't need this. I don't need this. Modifier, I think we're good already. Roles. Okay, so let's create something called roles. So I'm going to say D&D character, roles. The interface is going to be that this is going to be a nat to a random list nat. I don't know, might be okay. And then we'll actually define it. Why does this have an underscore at the end of it? Is that the way it's supposed to be? Huh. I'll have to look into that. I think... I'm not sure on that one. Okay, but in this case, we are going to try to create a random list. So we're going to go to Unison random. Why is it opening over there again? Okay, so here's random. Oh, yeah. Okay, we want lib base abilities random. Okay. So do we have a list like, oh yes, here's something. Random list of. Okay. I guess so. So I'm going to say random list of, and I'm going to put random, and then we want a nat, right? So this is generate a random nat between 0 and max nat inclusive. We want nat in. Okay. Oh, so this is not including J, so I'll put 7. All right, so that's list of, and then we're going to put the number that we want, right? I think. Oh. The length of the list is generated by the generator n. Oh, this is interesting. It's trying to show some text down there, I think. Oh. Well, this doesn't look very good to me. It's trying to show some text down here, but it's pretty hard to read. It's a tooltip bubble. Okay. All right, so I'll try that. Let's close that. Okay, so rolls is supposed to take n. Whoops. Do n. Okay. Now, do we have a random constant? Like in Elm? We have Boolean bytes either LCG. Okay. One of run a computation that uses random. Okay. Requires the IO ability. Split weighted. Huh. Uh okay. So for this, I'm gonna say okay, so now let's review the help again here real quick. So to do this, we are supposed to, in a different window, we're supposed to have UCM running. And that should be here in UCM. Okay, so now we are going to try to add the file. Not a valid source file. Okay, here we go. Let me expand that again. All right, so here is the first argument to random list of has type nat expected unit. Okay. Oh, interesting. Random nat in 1 through 7. All right, all right. Okay, so for that, do we do unit like that? No way. It says, oh no, that's okay, I think. Maybe? Found a value of type nat list where I expected to find unit. Okay, so nat random list nat. Huh. Okay. So does that mean we can get rid of the random ability here? That's surprising if so. Let's see. Ah, okay. Well, all right. I will add then. Okay. Huh. Well, very interesting. So that's crazy. All right, let's try this one then. So I guess that's maybe what we want. So now for ability, we are going to do roles for, should I do D&D D&D character roles 4. Okay. There we go. All right, now we used random map. Okay, so I guess what I'm noticing is, although a lot of the syntax of Unison is kind of like Elm, not all of it is, and this ability, this random ability seems quite different from the Elm random generator, right? And that's fine, that's good. Two programming languages definitely do not have to be the same, that's not required. But it's a learning curve. So in here, we're going to take this list of 4 roles, and then I guess that should give me a list. So I'll go list sort. List reverse. List take 3. List sum. There's no way. What's it going to say? Got confused here. I think I did use these things at some point in Unison, maybe. But if they're not going to work there that way, then that's fine. All right, so it's going to be list sort. List reverse. List take 3. List sum. The expression in red needs the random ability, but this location does not have access to any abilities. Okay, so that's going to mess us up, of course. So we don't have access to any abilities if we pass something into list sort. Okay. Random. RNG run. Shuffle split. Repeat split mix shuffle RNG. Doc. Let's look at Unison abilities again. Unison abilities. Okay, let's... Oh, it was right there. Right here. Okay. I think I would be curious to do this one in Haskell as well, to see how Haskell compares to Elm and Unison, right? Not trying to do it right now though, just trying to get this one done today. If I can get this one done today, that'll be a good win for me. I haven't gotten anything done today yet, have I? Okay, so let's look here. If I were going to be using unison, I would definitely need to read all this. Monatically inclined. Oh my goodness. Okay, so not that. Let's look at this part 2 here. Okay, so we used a handler. All right. So if we're on random, is there a handler for random? Handlers. Okay. This doesn't seem right. Okay, so do list replicate 10. Huh. Okay, okay. LCG1 do list map I random nat in 0 I nat dot star 100 nat range 1 through 11. Okay, so LCG is a simpler handler of this ability. Okay. Shoot. Oh, this is so crazy. The expression in red needs the random ability, but this location does not have access to any abilities. So, um, I might be stuck here for a while. Okay, let me try to write out like what am I actually thinking, if anything. So, shoot. Well, here, let's try this. Okay, now what does it say? All right, so list sum is not a thing. So we can look in base list and see if there's a sum or if we just need a fold. Either way is fine. Wait, where is list? Okay, I think it should be base. Where do we search here? List. List take. Shoot. Maybe it's not list at all. Let's see, I did text, unit, Unison programming language list. Okay. So it is list something. Where is it in the docs? Where is list in the docs? Okay, search. List. I don't think it's stream list. Why would it be stream list? I think it's just regular list. What is happening here? What is happening right now? List. Base. Okay. Lib. Data. Ah, here we go. So we could do a fold. So I guess this means there's not a sum, right? All right, so fold should be fine. Do we just want fold left? Yeah, fold left should be fine. Okay, so we put the list, no, we put the function in first, so that will be nat plus. Then we put in the init, 0. Okay, so now let's see what that does for us. Found a value of type nat where I expected to find unit to random nat. Okay. Okay. Let's finish up then. All right, so I guess this one is good. I don't know. Before going to that, let's go to load the test. Load, and then what does it say to do? We go and load the test file. Okay. So add, update. Huh. Okay. So all right. Okay, so how does this last part work? We're gonna be like, do 6, and then are we gonna use a case? In unison, do we have a case? Programming language, case, pattern matching, yep. Okay. Okay, so it's gonna be something. Let me review some of my other unison code. I don't have very much. Just the rotational cipher, I guess, right? Let's see what it ended up looking like. Huh, interesting. Okay. So this is going to be match, and then it's with. And we don't need a fallback necessarily. Okay, so let's not have a fallback then. Okay, so it's going to be SDCIWCH, right? And then that is going to be a character, so unique type. Strength equals S D and then what was the formula we used here? 10 plus D&D character modifier plus modifier of C. Yeah? Okay, what's it say here now? Okay, so found a comma, but I didn't see a list or tuple. Okay, so now let's look at record types, basically, or something like that. So it's we have unique type D&D character. Okay, so unison programming language, unique type record type. Okay, record type. There's no requirement for mentioning the field names. Okay, let's try again then. So it's gonna be D&D character S D C I W C H Okay, now what's it say? Got confused here. Okay, yeah, we don't want that. Okay, yeah, let's get rid of that. Got confused here on the S. End of input, new line, or semicolon. Okay, so it said, so we said volunteer. Wait a minute. Creating a value, there's no requirement for mentioning the field names. Preferred name, age. Record types allow you to define a type with individually named field names. Okay, so let's read more here, maybe. Record types. Okay. What's it say now? The first argument to D&D character modifier has type unit expected nat. Oh, interesting. So I think we just need to put do there, right? I think that I like a lot about this unison. It doesn't seem annoying like Reason ML, for instance. But, okay, so that's not quite it, huh? Unit to E1. Unit. Okay, so whatever we did there, it wasn't quite it. Same thing still. The expression in red needs the random ability, but this location does not have access to any abilities. Okay, so again, we might be able to just do this like before. It's very, some of this is kind of confusing, but okay. Found a value of type list of X, where I expected to find, oh, from right here. Oh, interesting. Okay. The expression in red needs the random ability. Okay. So I think we might actually not need that. So if we look at list, can we do like list of or something like that? Yeah, I don't think that's quite it. What's it say? Expression in red needs the random ability, but this location does not have access to any abilities. Okay, so let's look again. Okay, so how would we give it, how would we do this part? D&D character modifier. Um, these definitions depend on each other cyclically, but aren't guarded by a lambda. Okay. D&D, oh yeah. True. Um, am I getting there? Doesn't quite seem like it. Okay. Aren't guarded by a lambda. Okay, so it's the same thing, so let's get rid of that. Innocent programming language so I'm just gonna say, let's not do that. Let's do... What is that gonna say? Okay. Can't figure out what D&D character refers to here. Okay. So it's referring to the type that we have up here, right? Or that's what my intention is. It's crazy. Okay, couldn't figure out. I think its type should be... Oh my gosh. Yeah. I wonder what the I is there. Couldn't figure out what plus refers to here. Okay. I might be getting closer. I don't know. We'll see. Has type int, but I expected nat. Okay, let's try. The first has... Okay. So here, when we had an int, did we do from nat or something like that? I have from nat and to nat. Okay, so we want to look in here again. Let me close some of these. It feels like I'm taking forever. I mean, I have taken a lot of time, but it feels like I've taken a lot more time than I already have. It feels like I should be close to the 4-hour mark. And I'm glad I'm not. Alright, so... Alright, so let's close down data for a second. And let's look at int. So I don't see a from nat. Let's look at nat. What about abs? Do you think abs gives a nat? Yeah. Okay. Add. Update. Done. Okay, so now let's try the code. Or excuse me, I don't know why I said that. The test. Let's try the test. Okay. That was crazy. Let's try submit. That'll be a relief to get that one over with. That was... There was a lot of wildness there. Okay, so it says passed. Unison programming language. Command line source code formatter. Okay. All right, I'm gonna look this over and see if I want to refactor. So I'm gonna get rid of that part at the bottom. So this is what we've got. This part is fine. I want to say this part is fine. Honestly, I find this code very confusing. I liked the way the generator worked in Elm. Oh, it was a bit confusing, but this is very confusing. This random ability is very confusing. So, I'm still sold on Elm. Unison, it's kind of fun. I think it has some things to recommend it, probably, but man. Man. Okay. So let me go back to 48 in 24 here. And let me close these down. Okay, so we were looking at D&D character. Okay, so I tried it in Elm. I tried it in Unison. So in Elm, I'm gonna mark that as complete. And in let's see, sure. And then in Unison, I'm going to mark that as complete. Okay. All right. So I'm not gonna go back to Minesweeper Faro Smalltalk right now. That really, like, I think it was ridiculous in my opinion that it showed the solution. I'm not gonna try ABAP. I think that this is the time to try the spiral matrix. Okay, so spiral matrix. I think I'm going to try it in Elm first, because I have really had a good time with Elm in general. Okay, so spiral matrix. So I did it in Go, I did it in JavaScript, I did it in Visual Basic. How did it go in Visual Basic? I guess it was probably fine, right? So this one is a bit tricky for me. Wow, that looks wild. This one is a bit tricky for me. So I think I want to do it in Elm, but I actually think I want to do it in Python first. It's listed as a medium, apparently. This one honestly is a bit tricky for me. Maybe not, now that I've done it a few times. We'll see. Okay, so here's our Python file. We're going to get a size passed in. So we're going to say if size is 0, return this. All right. If size equals 1, return this, I believe. So well, hold on. Okay, so now we're going to go through, we're going to say n equals 1, while n less than equal to size squared. And we're going to say x equals 0, y equals 0. 0, there we go. And then here we are going to say, let's say result equals this. Okay. Let's actually go ahead and fill it in first. So we're going to say for in range size. Yeah, okay. So then at this point, we're going to say result y x equals n. N plus equals 1. Okay, so now we're going to say the thing is, so we have to go in a spiral, right? So we are going to say if, so we're going to have a direction. So d equals 0. Okay, so then we are going to match d. And I don't use the Python match that often. I hardly ever use it, actually. Let's take a look. Flow control. But match sure does seem like the right thing to use here. So we'll have match d case 0. And that's going to be if x equals okay, so I feel like it's gonna be def move, which takes xyd, and that this is gonna return a tuple of xyd. So we're gonna say xyd equals move xyd. Okay, and so I'm not gonna do this here. I'm gonna match here. So match d case 0 if, oh, we need to pass n in as well, right? Not n, size. So if x equals size minus 1, then return move size x, y, 1. So in that case we change the d to 1, right? Okay. So otherwise, return x plus 1 y d, right? Okay, so actually we don't need to recurse there. That's not necessary. So this can be a literal 0. So here it's going to be x y plus 1. Oh, wait a minute. So we should expect to never have to turn twice in a row, because then we're at the end basically, right? So that'll be 1. Okay. Case 1, if y equals size minus 1, return x minus 1 y2, return x y plus 1. Okay. Case 2, if x equals 0, return x y minus 1, 3, return x minus 1 y 2. Okay. Case 3, if y equals 0, return x plus 1 y 0, return x y minus 1 3. Okay, well that's goofy, but I mean that's basically how it's supposed to be, I guess. I think this approach will translate basically fine to Elm. I'm not sure. The while loop, perhaps not so much. We'll see. All right, so that's pretty much it. Now, when we get to the last one, so when we get to, so this should be less than, because the last one, I believe, needs to be handled separately. So the last one is going to be result y x equals n. Return results. I think that's it. Okay, let's black that. Let's test. Okay. List assignment index out of range. Okay, so that's messed up. And did it say that in every case? Looks like it probably. Let me just clear and look again. Alright, so we're off, but let's see. So our first failure, the size was 2. We expected to go 1, 2, 4, 3. But we got to list assignment out of range. So that's messed up. List assignment index out of range. So we wanted y and x, but we had no such luck. So if I'm in Python and I say a equals this, and then I say a sub 0 equals a, list assignment index out of range. Okay. So we have to actually fill that in, I guess, right? Okay, let's fill that in then. Okay, well, another one passed that didn't before. Haha. Okay, so we got it wrong. We got 2, 3. Okay, did we get the 4? We got the 5. And then the... Let's see. Alright, so the 1 maybe got overwritten or something. So we went 2, 3, good. 4 is in the right place, 5. 6, 7, good. 8, yep. Okay, so then instead of turning at the end... Ah, yes, that's right. So, yeah, it's a little trickier than I'd remembered. So we need a top and bottom and a left and right or something like that, right? I think I think that's what I had in JavaScript. That should that really be necessary? I don't know. I'm just gonna, here's what I'm gonna do. I'm gonna put an I for iteration, and we're on 0. And so then when we do this, we are gonna have to pass in an I. And it'll get passed back as well. So then this size is gonna be minus I instead. Let's start I off at 1. And then this is going to be... Let's start I off at 0. So this is going to be size minus 1 minus I. 1 minus. And then this is going to be I. Okay. And so then whenever we go to return, it's going to be I. In fact, hold on. Except right here. Here, we increment it. Okay. Still only 3 passed. Okay, so okay, so on our first failure, 2, 3, 4, 5, 6, 7, 8. Okay, so we still didn't turn. Messed up, messed up. Okay, so we're on our way up. So does that mean we increment this earlier? Yeah, so now they pass. Okay. So actually that is better than what I'd done before. So just using that I think is nicer. Let's try submitting, or let's try black and then submit. Interesting, interesting stuff. Okay, so it says passed, no hints. Okay, so let's look into possibly refactoring. So a lot of this looks like a real mess. So I believe this case should not be necessary. Okay. Is this case even necessary? I think yes. All right. Okay, so match D, case 0, 1, 2, 3. Yeah. Okay. I think that we might have more clarity if we just return everything at the end. So that means that here, I'm just going to say y plus equals 1, d plus equals 1. Yes, that's, I think, much more clear. And then here, we're going to say else x plus equals 1. Yeah, yeah, that's actually a big improvement, in my opinion, to the clarity of what we're doing. Okay, so likewise here. So this is going to be x minus equals 1, d plus equals 1. So this will be y minus equals 1, d plus equals 1, else x minus equals 1. Yeah? Yeah, I think so. X plus equals 1, d equals 0. So I'm just going to say, yeah, I'm just going to say equals 3. Messed it up. Messed it up. Now I want to undo. How many failed? Like all of them? Okay. So we went 1, 2, 3, 4, 5, 6, 7. Did I mess up the I? Okay, so hold up. Oh, I left out the I increment. So the I increment happens here. I plus equals 1. Okay. Okay, so now I think the next thing I want to do is refactor it into 2 different match statements. So it's going to be match D, case 0, if x equals size minus 1 minus I, d equals 1. Okay. Case 1, if y equals size minus 1 minus I, d equals 2. Case 3, if x equals I, d equals 3. I plus equals 1. That should be case 2, excuse me. Case 3, if y equals I, d equals 0. Okay, and so then there's a second match where we don't do any of this. We just do that. Right? So I think that's also good for clarity. Probably. Ah, I think it is actually. Okay. Okay, so now do we really have to do this result yx equals n again after the loop has ended? I think probably yes. Um, Maybe not. Let's just try it like this and get rid of this. Yeah, that's fine. Okay, cool. So now we could do for n in range 1 through size right? Wouldn't that be better? I think so. Okay, that's pretty good refactoring, I think. All right, anything... Oh, we need to get rid of this. I mean, I guess it didn't break anything, but it was clearly not meant to be there. Okay, so cool. Okay, I think I shall submit. Okay, all right, so let's go to Elm. Okay, so here's our file. So we get an int size, and then we do a list. Okay, so let's again say if size equals 0, then empty list, else, and then here, we're going to go through everything that we went through. And we can have a move int ah so the move I returned a tuple in Python, and I think that was good. In Elm, however, I don't know if we can necessarily do that. So we take these ints in, but honestly, maybe let's pass them in as a tuple, or as actually different tuples. So x and y like this. Okay, so what's that have to say for us? So so here we have to sort of like fill in the list that we want, right? So if we do like a list of, let's see. So the list itself, of course, has to be nested, but yeah. Oh, I'm trying to decide, do we have to use like recursion here? So like what if we tried to redo this like using recursion? Would that be a possibility? It could be, right? So def spiral loop. So now instead of a for loop, we're gonna take a size x, y, d, I, n equals 1, n result, I guess. And then when we loop, we'll say if n equals size square plus 1, return result. Okay. Otherwise, result. Let's put x, y, d, and I at the end maybe here. So let's put n result here, and then get rid of them there. Is that possible? So then instead of this, return spiral loop size 1 result 0, 0, 0, 0. Right, so then we don't need that. Is that gonna work? I don't know. Let's see. Yeah. Okay, so that's how we can loop it like recursively, right? So that's not too bad. Um, yeah, I think that's basically fine as far as I'm concerned. So, yeah, so if we don't have that iterative loop, then we can probably do it in a way very similar to this in L, right? Okay, so I'm gonna give myself a hint. This is a rather tricky one for me, to be quite honest. Okay, what's the Elm comment again? Okay. So I have two different match statements in the Python function for move. Maybe I should make it into two different functions in Elm. Maybe that'll be easier on myself. So I'm gonna say move D. Okay, so then we're gonna do case. And let me look at case again. I was just looking at it earlier, right? Maybe I'll start to get the hang of it. So we just do case. Case D of, right? Oh, what's this? I can close this now. Okay, and then we're going to do 0. If x equals size minus 1 minus I, then move x, y, 1 I, else move x, y, 0 I. Okay, so then we have 1, whoops, 2, 3. Okay, so then that's the same. Then this becomes just I. Okay, so then the move here is, in this case, 2, and in this case, 1. And here it's 3, and here it's 0. And then here is the special case where we increment I. And then this should be 2, and this should be 3. Okay, so then when we move, so I'm going to delete this part for now. Okay, so then when we move, we're going to have another case. So case D of, so 0 will be x plus 1, y, bi. Okay. Yeah. So that's that part. Seems okay so far. We'll see how it goes. So then we're gonna have spiral loop. So that's gonna be int list int x, or actually int int and returns list int. Okay. Spiral loop. So what's going to come in? Size n, result x, y, e, I equals, okay, if n equals Elm exponentiation operator, basics, cool, size square plus 1, then result, else so now we have to set a value in that list, right? So let's see how we do that exactly. So that is something that I definitely do not know. Let's take a look here at list. Singleton repeat range. Add to the front. Map. Okay, so if we use indexed map, then we can totally do it. That, I'm thinking indexed map is likely what it's gonna be. Okay, so indexed map will do the job for us, I guess. Indexed map. So it's going to be spiral loop. Size will go in there. N plus 1. Okay, so now here's where we go list indexed map, right? So now we need to put a function in there. So I think I'm going to define this function separately. Outer indexed map. So it takes an int no, list int list int. Okay. Okay, but then we also have to do another one. So int. Whoops. Whatever I just did there was not it. Okay, so indexed map. Okay, so that's that one. And then for inner, so this will take int, 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 I believe, right? So that's inner indexed map. And that's going to be x, I, e. Yeah, that's right. So if I equals x, then, and then what did we actually do when we got to this point? Okay, so here we actually have to put in the n, so I don't even have that. Okay, there we go. Yeah, there we go. Cool. Okay, so that'll go in there. Does that seem right? I think so, actually. Okay, so then when we go to else, we are going to go spiral loop size 1. So now we have to generate the initial list. Okay, so we can do repeat. So if you do repeat, all right, let's try. List repeat. Size, list repeat, size 0. Yeah, I think that's pretty much it. That's nice. That's actually nice. Okay, that's all she wrote. Let's see what it actually says when I start to run it. So let's first Elma format. Oh, unable to parse? Okay, so Elma make source. Okay. Oh, well, that's a typo. Not expecting to see an arrow. Looks like another typo. That is on here. Cannot find a size variable. And that is on 7. So the size was not passed in, but it needs to be. But this one shouldn't need the size. Okay, so what's this hint? Oh, we need a... We need this. So if that happens, then I'm just going to give one back unchanged. But it shouldn't ever happen. Okay. Okay, so here... Oh, that exploded. All right. Wow. Well, okay, let's see what the test says. Okay, so something passed. Let's get rid of the skips. Okay. Pass 2, failed 4. All right, so I ended up with zeros here. Okay, so that's not good. Obviously. All right, so 1, 2. We didn't end up doing those ones. So I think I messed up these indexings, probably. So we did outer indexed map, nxy, I row. If I equals y, okay. So yeah, it looks like the row did in fact get passed back unaltered when they didn't match. Oh, wait a minute. Um, so yeah, in every case, we only did the first row, right? And everything else ended up unaltered. Messed up, messed up. Okay, so Elm REPL. Not found. Oh, have I not used it yet? Interesting. Okay, let's see what this does for us. Package Haskell org. Okay. Hopefully it'll be fine. It's getting close to the time that I'm supposed to stop. Well, yeah, kind of close. I don't think I'm going to finish this in pure script, but I will be back tomorrow to go back at it. Oh my goodness. A lot of issue there, it looks like. Okay. Could not resolve dependencies. Oh no. I was worried about that. Okay. This is from 2013, apparently. That's more like it. Okay. So that stuff from 2013 was way out of date, I think. Okay, let's look at this. No, let's not do that. Let's look at this. And Elm REPL. Lovely. All right, so let's try this one first. Trying to paste it in at the REPL didn't seem like it worked very well. I feel like we're gonna have to go put it all on one line or something. Or, wait a minute. Okay, let's look here. Okay, let's try importing. Okay, so I want to expose everything that I've got here. So move D, move, inner indexed map, outer indexed map, spiral loop. I want all of those because I want to be able to try them all. Okay, so now if we go in Elm REPL and we try to import my module, which is spiral matrix, right? Okay, so now can we try move Do we want spiral matrix move? Ah, okay. So move D is the one that's supposed to take the size, right? It went back to the starting position. So we started at the top left. Okay, I think we hit all 4 positions. So it's probably good enough then. If we do it with 3 and we start zeroed out, then we move across to 1, we move across to 2, we move down to the next row with the direction changed, we move down into the bottom right corner, we start moving left with the direction changed again, we move into the bottom left corner, we start moving up with the direction changed again and the iteration incremented. Now we go into the center, and I mean, that's it, right? Okay, so my phone started buzzing like a madman. I don't know what that's about. Okay. So I think the move seems okay. I think it's more likely that there is a problem in the, in what are they called? The indexed map functions. So let me cat again. The outer indexed map or the inner indexed map? So I'm going to go elm REPL import spiral matrix. Okay, so now let's try the inner indexed. I think the problem is in the outer indexed map. Maybe? So when I go spiral matrix 1, 2, yeah, so there's our problem. So if I go, let's see. Outer indexed map. NXY. So let's see here. So N should be 1 to start off with. These should be 0. Wait a minute. I think that should be fine. Okay, so those are 0. And then this should be 0, and then this should be like this. Okay, so now if x is still 0, but let's say that now y is 1. And what if this is 1? Okay, so that part is fine, right? Okay, now what if this is 0? Then we get it back unchanged. So that seems right, I think. So I think something wrong is getting passed in here somewhere, I believe. Now I'm looking at it and I'm like, brain mush. My brain is like mush. Um, is this the right order that they're going to be passed in? I and row? Shoot, I need to check that. Yeah, should be. Indexed map tuple dot pair. Sure. Starting at 0. Yeah, I think that's as I expect. Yeah. Where, oh where have I gone wrong? Wait a wait a minute. No. This list dot repeat. I think I need to have print debugging going on. Okay, let's see here. Elm print. I think I've looked at something about it before. Elm. Result. Error handling. Okay, so let's say list indexed map spiral matrix outer indexed map. Okay, we're going to pass in nxy. So that's going to be 1, 0, 0 to start with, I guess. list repeat. So I'm gonna say 4, maybe. List repeat 4, 0. Okay, so we've got the 1 in there. Now, if we want to put a 2, and now the x is 1, so there it is. If we want to put a 3, and x is now 2, there it is. If we want to put a 4, and x is now 3, there it is. Okay, so now x is still 3, but y becomes 1, and we want to put a 5. Ah, so it is there. So let's go spiral matrix spiral loop and pass in 4, 1. List repeat 4. List repeat 4, 0. Zero, 0, 0, 0. Yeah? Okay, so yeah, so that's the result that we get. So it's like y is not becoming incremented, I guess. I don't know. So x is becoming incremented, that's good. So we get xy di, or something is happening here. So let's say 5 equals 4 square plus 1. So false, because this is going to come out as 17. Great. So we're going to move 0, 0. Wait a minute, wait a minute. Oh, I called the wrong thing. It's supposed to be move D. Okay, I think that's the only problem. Took me a while to see it. Pretty obvious now. Okay, so it's move D. Well, that took me a while to see it. Okay, so that's passed. Let's try Elm format. Yep. And then I think I'm good here. So I'm gonna mark that one as complete. So I'm falling further behind because I only finished one today, right? The only one I finished today was the D&D character Unison, which was a good one to finish, for sure. But I'm falling super behind, actually, honestly. So tomorrow, the plan for tomorrow is to go into prologue. because I have 3 that I have to complete in prologue, right? Isogram, knapsack, and zebra puzzle. I want to say I should be able to knock out all 3 of those tomorrow. And then once I get those done, the plan is to then move on to JQ. JQ, it's very confusing, but I have a hunch that it won't be so bad once I start getting into it. And yeah, that's the plan. So this one really annoyed me. I couldn't believe it. These 2 I want to finish after I've finished it in prologue. This one, at the very minimum, I have to fill out some big form before I can download this. This one should be easily doable now that I've done it in Elm. I guess easily doable. PureScript is similar-ish to Elm. This one I had trouble installing. This one I had trouble installing. I haven't decided yet, or haven't figured out or discovered yet what to do about these 2. Then these are definitely on the menu for tomorrow. Knapsack is a relatively simple one, so we'll see how it goes in prologue and JQ. And there's this one. Okay, so these 2, there's not any particular reason that I've held off on these 2. So hopefully they won't take forever. But yeah, I'm falling a little bit further behind, but hopefully tomorrow